So let's start our review for the final. And I wanted to start out by listing the chapters and topics we covered. So in chapter 2, we started with logic of compound statements. Chapter 3, we dealt with logic of quantified statements. Chapter 4, we had methods of proof. Chapter 5, we talked about sequences and mathematical induction. Chapter 6, we talked about set theory. Chapter 9, counting and probability. And then we ended in chapter 10, where we talked about graphs and trees. So in these videos, we're going to review some of these topics, and I'm going to focus primarily on the earlier material. So let's remind ourselves what's a statement. A statement is a sentence that is either true or false, but not both. So let's look at a few sentences and decide if they are true or if they're statements or not. So today is Tuesday. X equals 3 for all real numbers. X equals 3. So let's look at this first one. Today is Tuesday. Well, either today is Tuesday or it's not Tuesday. So either it's true or false. It can't be both. It can't be Tuesday and not Tuesday. So this is a statement. And if we look at x equals 3, we don't know what x is. So depending on the value of x, it could be true or it could be false. So it could be both, which means this one is not a statement. But if we look at this statement down here, this is the sentence down here. Now I have a quantifier for all real numbers. And so now I'm considering every single possible real number. And this equation would not be true for all of those. So this statement would be false. And so this is a statement. So then we talked a lot about truth tables. So let's look at a few examples where we construct some truth tables. Construct a truth table for the statement form. P or Q and not P and Q. So if I look, how many variables do I have here? I have P and Q. So I have 2, which means there's going to be 4 rows in my truth table. false, true, and false, false. Okay, I've got my 4 rows in my truth table, and now we're going to start by constructing these pieces that we need. So if I look at my statement form, I see that I'm going to need P or Q. So let me make a column for that. And I only need one of them to be true for this to be true. So true, 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 false. And then I'm going to focus on the second part on the inside of the parentheses. I need P and Q. So now they both need to be true. There's only one time that's true. And then I can take care of this negating, not P and Q. Flip the entries in that last column. And then finally, we can put together all this into our last entry, P or Q, and not P and Q. So now I'm looking at this column right here, and this column right here, and I have an and between them, so they both need to be true for it to be true, false, true, true, false. And there's my completed truth table. So let's look at one more truth table problem. So what I want you to do is construct a truth table for the statement form P and not Q or R. So if I look, how many variables do I have? Well, I see a P, a Q, and an R. So there are 3, which means my truth table has 8 rows. True, true, false, true, false, true, true, false, false. And then you repeat those 4, but change P to be false. And false, false, false. Okay. So again, we're going to construct this in pieces, and we're going to build out what we need. So one of the first things I see we need is not Q. So let's go ahead and do not Q. We're just going to flip all the entries in Q. False, false, true, true, false, false, true, true. And then I need, going back to my statement, I need not Q or R. So an or, you just need one of them to be true. True, false, true, true. And then this next one would be true, false, true, true. And then we can make our final column in our truth table, which is P and not Q or R. So you're going to look at the P column, very first column, not Q or R column, and then you're doing an and between them. So they both need to be true to write down a T. So here it would be true, false, true, true, and then the last 4 entries, P is false, so it'll be false, 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 and false. And there's your truth table.